Trig game song? If you want to.
It'll be worse than that.
Sounds awesome. Sweet ass toast. Comes from Mercury Rail and authorized. Are you okay?
She was letting her cousin and her eye just, I was like looking at her, she was like, oh yeah, her eye disappeared.
I just remember
Yeah, the letter E, that was awful.
yeah.
Yes.
Oh, I think that the one you showed us is
There's your standards are lowered. If I can make you at least laugh, I've done my job. Anyway, when you get to a quadrantal, remember, as soon as you land on a quadrantal, you have to write out the ordered pairs. Okay? Always write out the ordered pairs when you're on the quadrantal. Here it tells you at negative 90. Well, your ordered pair at negative 90 is 0 and negative 1. Sine, what comes first in the alphabet? Cosine or sine? Cosine. Comes first in the alphabet, x or y. So sine goes with y. What is your y value at that coordinate? Negative 1. You have to ask yourself those questions, guys. That's the one that most of you will get wrong. You've got to remember to ask yourself those questions. Okay. Let's see. So was there any on that front page you would like to double check and peruse or go through? I know the answers were, if you looked on the calendar, the answers were posted on there. I didn't do a solution key, I just let the include answers show up. I think it was, Okay. Number 5. Johnny, negative 210. So, let's see here. Negative 210, spun around your second quadrant. What's your reference angle if you came up off of 180? 30, very good. So we have a reference angle of 30 degrees. Opposite your 30 is the 1, adjacent to it's the negative root 3, and your hypotenuse is 2. And I forgot which one, this one was a cosecant. So cosecant is the excuse me, is the reciprocal of sine. Sine is positive in the second quadrant, so therefore cosecant will also be positive. Sine is opposite hypotenuse. Your opposite is 1, your hypotenuse is 2. So the reciprocal of that is 2. I think the second page had a lot of, we started to get to some more of the pies and stuff. What do you got second page to roll through? Which one? 15? Absolutely. 15 says secant of negative 25 over 6. So as you spin this one around, which they did for you, which was rather nice. Remember, this would have been 6 goes into 25 4 times with 1 left over. That's why you went around 1 little, 2 little, 3 little pies, 4, and you dropped. Your reference angle was pi over 6. Pi over 6 is which degree? 30. So you're 30 degree down, which means your opposite is the negative 1. Adjacent is the root 3. Hypotenuse is 2. Secant is reciprocal of cosine, very good. So cosine would be root 3 over 2. Secant would be 2 over root 3. Now, what happens here, we have to just rationalize, and hopefully by now we all know the shortcut. It's good times. What else? Second page. Third page, the same basic stuff again, it's just all radians all the time. I'll have a mixture of degrees and radians just like we have been doing. Okay. when you're trying to plot and find your angles. What do you got for the third page?
When we find it, like on the test, find it in degrees.
When you're doing these, your answer is going to be the roots and stuff.
Oh, okay.
When you're searching for the angle, you'll leave it in radians. Okay. And we'll get to those. That's on that. That's more on that secondary sheet. And I'll remind me to say that again. I'll get there. Yes, sir. Sure. Cosecant negative 25 pi over 6. Hey, we were just there. So we were just at that angle. So you knew that this reference was the 30, so you're negative 1, root 3, and then 2. Cosecant is the reciprocal of sine. So sine here would be your opposite hypotenuse. So negative 1 over 2, otherwise, and then you flip it, you get, there you go. Excuse me. I do. You did it right both times? Because I wrote it on. Go. Oh, I just pressed the button. It's a big problems.
Oh, shoot.
Oh, yeah. I would tell your mom you're mouthing off. You'd probably say I deserved it.
If it was in the daily, I'd probably give it a lot.
Yeah, you're probably right. If it's me or Fontana, she'll be like, no. We've dealt with it all your lives. Then we get down to the last bit. Trig of an angle. Terminal sides. Yes, ma'am. 27. Secant of theta when you're placed here. Now, this is the style of problem. Excuse me. You have to remember how you set up and found your radius. Here, you have to draw the right triangle in. You have ordered pairs. Your ordered pair is the negative 2 root 3, the 2. You have to solve for the radius. Remember how we did that? The radius was the square root of x squared plus y squared. Well, obviously when you square the negative 2 root 3, it has to become positive. Yes, sir. It is. What's the 90 going to be? Correct. In this case here, you're right. You recognize the pattern. Did everybody see that? There's the opposite's the 2, the adjacent is the 2 root 3. So it's a 30, 60, 90. So the across from the 90 has to be 4. So if you didn't recognize that, you can just do, well, 2 root 3. When you square 2 root 3, remember what you're doing. I'm going to disregard the negative because you know it's got to be positive. This means 2 squared times the root 3 squared. The square root of jump squared is jump. So what's root 3 squared? What's 2 squared? 4 times 3 is 12. 12 plus 4 is 16 squared and 16 is?
You said 14.
It happens a lot. So there it gets you to the radius proportion. So whenever you're doing this style where you have the ordered pair on the terminal side, you just solve the Pythagorean theorem real quick and go from there. So they're asking for secant. So secant is the reciprocal of cosine. Cosine in this case would have been negative 2 root 3 over 4, which is negative root 3 over 2. But then I have to reciprocal it. So I get negative 2 over root 3, which then becomes negative 2 root 3 over 3. Okay. This style usually has a bunch of simplifying to do. But there won't be any numbers that are difficult that you cannot figure out. Whether it's simplifying a square root or a fraction. Okay? I made sure to keep them clean. I checked my work. Hard Yes, it'll look just like that. It might give you Find the secant of theta to give an order pair. I probably won't draw it in because I'll leave that up to you. It just means that's which way it's going. It's still a reference angle. It's still going to be placed in that same spot. You know what I mean? It's okay. That's what you're looking at. All right. Yes, sir. Very well. All right. Yeah, that's what they'll look like. It'll just say, hey, what's the cosecant value of theta with the given order pair? Basically, I try to keep away from not giving you guys all the diagrams so much. I want you to figure out what quadrant you actually wind up in, and you can do that kind of stuff. So, any other of those? Yes, Nate, what do you got? 32? Sure. So this one I have cosecant of theta at -5, negative root 11. So it was cosecant theta when it was at -5, negative root 11. So let's see, -5, negative root 11 here-ish, down and up. My x value is the -5. My down value is the negative root 11. So let's see, 5 squared is 25. Square root of 11 squared is 11. 11 and 25 is 36. Square root of that is 6. Cosecant is the reciprocal of sine. So sine here would be negative root 11 over 6. So this would be 6 over negative root 11, which is negative 6 root 11 over 11.
That is beautiful. Well, the first alignment a little bit. It looks like it was more. No, I used to I didn't say
No. Dehydrate dye.
Okay. Hydrate or dihydrate?
Hydrate dye. I like that one. Hydrate or dihydrate. It's good.
We always say don't let it be dehydration ruin your vacation. That was really stupid.
You say that so we can invent.
What else we got?
Wait, what? You go in order of age.
Yes, ma'am. What do you got?
Wow.
How to get what? That right there. What's 2 root 3 squared is 12. 2 squared is 4. 4 plus 12 is 16. What's the square root of 16? That right there. Okay. Any others on this one, or just flip over to the what angle has? What angle has? So on this one here, if you went online, you saw the answers. They gave answers all in basically degrees. I want all answers in radians for these, okay? Just like I have been doing. Because when we did our first set of notes with this stuff, I always said sine being searched between pi over 2, negative pi over 2. Cosine was 0 to pi, tangent was non-inclusive pi over 2 to negative pi over 2. So make sure you keep that straight, because that's what we do. Okay. On this one, what did we want to look at as far as when you do what angle has? Why do I talk so weird? I had a coffee. It was just a little. Sorry, Miss Perfect. Jeez. Yep, that's what I got.
You're number 9.
Sure. What angle has has a tangent of root 3 over 3, negative 3. So, the term arctan means the same thing as tangent inverse. Okay? It means what angle has tangent of negative root 3 over 3. So what happens here is it being negative, we know tangent's being found between pi over 2 and negative pi over 2, non-inclusive. Okay? So we know it has to drop to the fourth quadrant to have a negative angle. When you see, anytime you see root 3 over 3, that means it's been rationalized. It's one of those words. It's been rationalized. What is the unrationalized version of root 3 over 3? 1 over root 3. So this is the same thing as saying negative 1 over root 3. Now, tangent is opposite adjacent. So that means my theta is placed here, and I'm looking at a negative 1, which makes sense because it's the down. My adjacent is the root 3, which means this has to be the 2. What angle is opposite the 30? What angle is opposite the 1? 30.
45.
I gave the answer away as a mistake. So the angle across from the 1 is the 30, but in this case it's negative 30. But we write this as negative pi over 6. Yeah, good.
That's negative. It's in the third.
Tangent's found between pi over 2 and negative pi over 2. It's negative, you gotta drop down this way. That's how you find tangents, first and fourth. But yet it's not technically the fourth because it's not, because it's not between 270 and 360. Hold up. I unrationalized it so I knew what to write. If it's the same, just like we did yesterday, whenever you have the same number that's in the radical as the denominator, that means it's been rationalized. So if you see root 3 over 3, it's 1 over root 3. If you see root 2 over 2, it's 1 over root 2. That's the case. Those are the two cases that that's found. What else we got? The double? Which one? Which one? 22. So what is the sine of the angle that has a cosine of root 2 over 2? Again, this falls back into you work with your order. You work with your order of operations. Oh, that was my niece cracking stuff.
I heard it.
Yeah. So as you go through this one, notice it's cosine root 2 over 2, which means it's first quadrant cosine. Unrationalized, that meant it's 1 over root 2. So basically what this means, first of all, what angle has the cosine of 1 and a root 2? Well, that has to be 45. Is that okay with that? So that means that this portion here is pi over 4. Now you've solved the innermost parentheses, so you go back to the next part. What is the sine of pi over 4? Well, it just so happens I can use the same diagram in this case, and I place my theta here because there's my pi over 4. My opposite's 1, my adjacent is, my hypotenuse is root 2. Therefore, my sine is 1 over root 2, but otherwise known as root 2 over 2.
Oh, wow. Oh, yeah. Okay.
So just undo it.
No, it just so happens. Remember the 45, 45, 90, since it's isosceles. Isosceles. Your opposites, your two angles, your opposite, your adjacent are always the same. Yes, ma'am.
We're going to do 25.
Okay. What angle has the sine of 7 pi over 4? Okay. So we start. We got to find the sine of 7 pi over 4. Well, 7 pi over 4 drops you to the fourth quadrant. gives you a pi/4 reference angle. The sine here would be -1 and a √2. So your sine of 7 pi/4 would be -√2 over 2. Okay? Now, going further with that, the next question says, what angle has the sine of -√2 over 2? So when you go to search for what angle has, you're not talking about 7 pi/4, you're looking at it between pi/2 and -pi/2. Well, this one drops again to here, which means this has to be -pi/4. Remember, when you are searching for sine, you're between pi/2 and -pi/2 in this instant. When they ask you for the sine of the other angle, you can spin around to get to it, but then when you search for it, you go back to your parameters. So you have to remember how that works. Okay. A lot of times people will just write 7 pi/4 for this answer because they think the sine inverse and the sine does it. It technically doesn't because it switches search criteria.
But the sine of the cosine.
In that case, because it was a 45, 45, 90 in the first quadrant, right?
Yeah.
If it wasn't a different quadrant, your sine's SIGNs could change. Okay. What else we got on that one? Cosine of tangent, -1. So first of all, it says, what is the tangent? What angle has a tangent of -1? What angle has a tangent of -1? And then what's that cosine? So tangent negative, it's got to be down. In order for tangent to be a -1 or a positive one for tangent, that means your opposites and adjacents have to be the same values. The only time that happens is with 45, 45, 90s. Okay. So that means that I have a tangent value. This guy is -pi/4. Okay. Now, what is the cosine of -pi/4? In this case, I don't, because this is still it's still the same reference angle here, isn't it? Because you just drop, because now you can draw it around, but you still drop to the fourth quadrant. No, yeah, and that's, you just gotta be careful what you're searching for, okay? When you're searching, you'll see the negative. Okay? If the negative will either be on the inside or the outside, it won't be double. So here you get what angle has the cosine, or what is the cosine of -pi/4, which is just gonna be √2 over 2.
Yeah, I got that.
We hope. Let's see. What was the only thing we didn't talk about yesterday? Oh yeah, sectors and arc length. So remember sectors and arc length? Those guys were, what section was that? That was the first one we did, wasn't it? I'm drawing a blank. Yeah, it's all on calculator stuff. Whatever we've done without a calculator. Was that 13.2? Yeah, it was. So remember when you did areas of sectors and arc length, we would use one set of values and just do it twice. To find the arc length and the area of the sector, we can give them information. Usually what would happen, what's that one? Here. Nope. Radians, degrees, that's easy by now, I hope. Here it is. So when you're doing arc length, area of sectors, remember arc length was just radius times theta. Theta has to be in radians. And then area of the sector was 1/2 radius squared theta. Again, theta in radians. So the examples that we did were real simple. Theta's in radians, that's too easy, so I'm not going to do that. We'll say the radius is, we'll go back to 3, then we'll say our angle, we'll change it up, we'll say 120. Okay. We'll make it switch out and have to do both. So when you're switching from radians to degrees, degrees to radians, divide by 180 and slap a pi next to it. All right, so the arc length, central angle, 180, slap a pi next to it, multiply it by your radius. From here, it's simplifying fractions. When you simplify these things, zeros drop. I'm doing arc length first. So I do the arc length, then 3 goes into 18 6 times, 6 goes into 12 twice, your answer is 2/5. Okay? The simplifying of the fractions for these should always be really, really fast. Same idea if I go to area, if I do the area of the sector with that same information, area of the sector, same thing, you gotta do your central angle over 180, this time, then it's times 1/2 radius squared, and then our radius was what, 3 squared, and then we still need a pi. Okay. 3 squared is 9. So I drop my zeros. This becomes a 9. 9 goes into 18 twice. 2 times 2 is 4. 4 goes into 12. 4 times, your answer is 4 pi. Something squared. I was thinking 4 times. Yes. I was making sure you were paying attention. Congratulations.
Oh my God, dude. Just looking at the date, I realized it.
Sector. Here in the sector. They shouldn't be tough. I mean, it's just fractions. Be afraid of the fractions.
I was looking at videos and one of the videos didn't show up. Was that just I didn't play the video?
Did you try third hour? I don't know why that happened. Try third hour. The same one. Let me know which one it was, and maybe I'll try and reverse it.
It was not 20. It was 27. Thursday.
I don't remember what we did Thursday. What else you got questions on? What style? See, we're not.
It was 13.3.
Okay.
Yeah.
Look at third hour one. See if third hour goes. That's weird. I wonder if it got zapped in the middle of doing something. It might have got caught in an
No,
update.
it says it's private.
Did you check the third hours?
I'm gonna check their address.
Check third hours real quick. See if that happened again. I don't know.